Oh, welcome everyone. Thank you so much for coming on the last day of the conference, and especially 9 in the morning. I'm sure you guys probably had a lot of good time last night. So thank you so much. So let's do a quick intro. So Ken and I are going to be talking about how we can scale the edge deployment using desired state. And so Ken, do you want to?
Yeah, my name is Ken Guo. I'm a technical product manager with the Edge Compute Stack team.
And my name is Xiao Gao, and I am part of the architecture engineering team at Broadcom, same BU as Ken. So, yeah.
Right, so we're going to go through the standard disclaimer page. So let's talk about the product vision first. So the product we're going to talk about today is Edge Compute Stack, and Edge Compute Stack is part of the Software-Defined Edge business unit, or SDE BU. And right now, what we want to do is the BU wants to deliver a portfolio of products that's very much focused on allowing and enabling customers to deploy Edge AI at scale. Also security and efficiently, right? So Edge Compute sits on top of the stack, and there are multiple offerings within our BU, including SD-WAN as well as telco cloud platform. Right, so what our leaders like to say is they want to deliver Edge Compute Stack as the leading platform to enable customer to deliver AI at the edge, sitting on top of intelligent overlay and the underlying network. And they want to do it in a 3-prong or 3-layer of approach, as eating a cookie, if you will. So let's kind of get to know you a little bit. How many of you are VI admins, come from the virtualization space? Okay. Developers? Okay. Are any product people? Okay. What about SREs? Okay. Awesome. All right. How many of you have been here all week, since Monday? Okay.
That's good.
How many of you have really sore feet? Okay. All right. So yeah, appreciate you being here. It's my 5th day, and really appreciate you being here this early, especially on the last day. So here's the agenda for today, and what we really want to focus on is actually the demo. I know it was meant to be a small piece in this overview, but it is a 90-minute session. And from my past experience of doing this, in the past, I always felt like there wasn't enough time to actually demonstrate the product. So we're going to give an overview of Edge Compute Stack, but then mostly focus on providing a demo so that you can see, what we mean, right, when we present these slides to you. I'll let you get started.
All right, cool, thanks. So yeah, actually the hand raising, trying to see what everyone does, is very important to GitOps, because GitOps is not just a technology, but also a process as well. A process where, depending on your organization, everybody have a role, right? And then how you do GitOps is going to be different from how other company may do it based on how your organization is aligned, right? So that's why the previous slide was both an icebreaker as well as just sort of setting the stage for, the GitOps is a process in addition to technology, right? So first thing is what is GitOps, right? So before GitOps came along, we had this sort of what we call the direct access method of doing configuration and maintenance. And so what that means is that you have your SREs, you have your network VI admins, network admins, effectively SSH directly into a ESXi host, and then, or maybe using your vCenter UI to create the right objects. Let's say if you're creating a virtual machine, you go in there and say, okay, let me first define what network I want to have, Then you say, okay, what operating system, I need to, if I'm installing from scratch, I need to add a CD-ROM to the virtual machine, right? And it has to be very sequential, because if you don't create the network and you started like, attaching a random segment to it, you don't, end up with what you have, right? So when you have this direct access method, is very powerful. You have a lot of control, right? You can say, oh, instead of an 80 gig disk, I want 85 gig. You could do that, right? Because you are in complete control of every single low-level step. It's kind of like, back in the programming days, when you write stuff in, assembly code, right? In machine level language, you could write it extremely fast, extremely optimized, but it's just hard to maintain. It's operationally complicated. So imagine if you have an edge deployment and you have to go to every single device and then click through the button and make sure that, you're doing the same thing over and over again. It's doable, but maintain that consistency and make sure that every single infrastructure is deployed identically becomes a challenge. So when this is becoming an issue when everything was in the data center, it's not a big deal, right? But when you have thousands of sites to maintain, then that operational drift, so to speak, between, like in your case, kind of a ship one versus ship two, you spend days to troubleshoot things, right? Because, some parameter that was defined wasn't done correctly, right? So that's what we call the direct access method, right? And a lot of people, the way they address that is like, I have automation. We talked about this before the call. It's like, before the meeting, not the call, sorry. Is that, hey, I have Ansible, I have Terraform, right? I could automate everything I do so that I could just run a script, right? But imagine maintaining an inventory. Let's say you have 3,000 sites, maintaining an inventory of pass and fail, right? And which sites do rerun. And then because the automation is a lot of time homegrown, and then you have a lot of variation in your infrastructure, right? Tracking just the results of the automation becomes a huge challenge in itself, right? So that's, that's the way, it works for data center. It's very powerful. And I think, if you're managing infrastructure, again, it comes down to organization processes as well, right? If you already have a great process in place, that's awesome, right? Can we go back to the previous one? Sorry. Then the new way, the way we're talking about is this sort of, like you guys hear about configuration as code, right? Configuration as code is like Terraform, it's like Ansible. But this new way of doing things is GitOps, right? It's using YAML file. And they basically, it's instead of you coming up, even, the automation steps, you basically say, here's my desired state. I need a virtual machine with t-shirt size of large. And then behind the scenes, the large virtual machine maps to a CPU, 16 gig of RAM. I mean, random numbers here, right? So your things may be different. And then you can define your own t-shirt sizes depending on your application types that you run. And it could be like a tiny VM with one CPU, right? With 2 gig of memory. Or it could be some, manufacturing virtual PLCs that's developed, that's recently refactored to run in a virtualized environment, right? So you have a lot of flexibility, and then you let the underlying infrastructure itself configure that workload. You don't have to go in there and define 80 gig of disk and all that stuff. You would just automatically, depends on the definition file you push to the Git repo, it will automatically configure. And how does that work? So, oops. Yeah, so how does GitOps works, right? So you have, I only draw one person, but in reality, you have your software developer that's writing code, building applications. You have your VI admin that is, instead of, going to ESXi using vCenter to configure port groups, to configure like vSAN, right? You have basically defined your YAML definition. So, or you could have QA, You may have a person that does a lot of performance testing, right? So you validate it. You say, you know what, this application needs to have to get to the scale that you want. You need to have X number of CPU and memory. So you really pretty much that one, the first icon there. It could be like, whichever persona you have, right? So you have basically they're all responsible for a certain part of the infrastructure, right? So let's say that the developer releases the next version of the software. It does it goes through the CI/CD pipeline. It generates an artifact. The artifact gets pushed into some sort of a registry, and then that registry has a version associated with it. And then it depends. Later on, I'm going to talk about how we actually maintaining those versions. What is the best strategy we need to do? But they will just update the Git, the new version that they want to deploy. Right? You put it into the repository there, and can use there's pretty much anything that whether it's infrastructure, whether it's application, it could be services that you're trying to launch. Everything goes into the Git repo, right? And then what you have is they have the artifact, which is your container images or VM templates, right? And they have this thing called a Git agent. So what is a Git agent? Git agent is something that looks at the Git repo and compare the desired state with the running state. If the desired state doesn't match the running state, then what it's going to do is it's going to make sure the running state matches the desired state. Right, so you will go through this loop continuously, and example will be like in release 1 of the software, you have 2 CPUs and 4 gig of memory, and then in release 2 you did major optimization. Like later when we talk about AI, like you use Ultralytics as the training model, and then use it for inferencing, but it has tons of packages, right? So you rewrite the whole thing in OpenCV. The code drops to 1 gig instead of 6 gig when the image was built. So you can drop the t-shirt size. Instead of you going to the virtual machine and do all this stuff, you can just update it. And later on we talk about Ken is actually going to go through all the objects you're going to define in the Git repo, right? So what are the core principles for GitOps is everything must be declarative. This is the number one thing, right? And this will help help you scale, right? You define the desired state once, and you can push anywhere you want to. And then it has to be version. You need to have a good version strategy. And later on, I'm going to talk about how do you maintain different versions, and how do you promote the versions between across your deployments and sites. And then it also needs to have automation is the key. No manual changes, right? You don't ever go to the infrastructure. If you're using GitOps, you don't try to say, let me just log into the infrastructure and make a quick change, because it won't allow you. Even if you change it, it's sort of you're having a drift. So GitOps will automatically reset it to the desired state. So you have to go through Git. Everything has to be automated, right? And then lastly is that the agent itself will make sure that everything will run based on the desired state. So I think the next slide is, we're going to do an overview of Ken's going to do an overview of the Edge Compute Stack.
Yeah, so just to be clear though, there are obviously other GitOps principles, but those are the ones I think we want to focus on for the Edge Compute Stack as a product. So, version control, declarative, continuous monitoring using Flux, and then continuous reconciliation, right? When there are deviations or somebody makes a change locally, you want that to be reverted, right? So, yeah. So next we'll go over the Edge Compute Stack architecture and overview. So we'll first start with the management plane. So I think VMware Edge Cloud Orchestrator was announced last Explore. And what we're doing here is Edge Compute Stack is now a new module in the VMware Edge Cloud Orchestrator, which currently is hosting the SD-WAN service, but now it's also going to be used as the management plane for the Edge Compute Stack. Okay? And if we look at the solution, overall, you have on the left-hand side, you have the VMware Edge Cloud Orchestrator as the management plane for this solution. You obviously have the hosts that you deploy on site at your edge locations. They can be a single host, two host cluster, multi-node clusters, and they run a edge optimized runtime to be able to run both VMs and Kubernetes equally. And what we mean by that is when a node comes up and it connects to the VMware Edge Cloud Orchestrator, at that moment, it automatically bootstraps itself with a Kubernetes control plane as well as a Kubernetes worker node. So essentially, it's a single node cluster that is always bootstrapped, and it comes up automatically. And the goal is for the product is to really, on the right, there are the three objectives, main objectives we want for the product. And then right under them, right, you have the features associated with them. So first and most is this Edge Compute Stack has been focusing on the retail manufacturing sector, and therefore we want ability for Edge Compute Stack to run both real-time and non-real-time applications simultaneously. And in real-time, we mean applications that have very low, ultra-low latency requirements, and then ultra-high availability requirements. And what we mean by that is something like a programmable logic controller, if you are familiar with that. I see a couple folks who are obviously familiar with it. They essentially control physical things in the world. So in let's say a manufacturing space, they'll be controlling the robots that are used in the robot cells to produce cars. And therefore, they require ultra-low latency that typically is under 1 millisecond or even lower. And then in those cases, for safety features, 5969 is actually not enough of availability. They literally need to be 100% availability. So so what we want to do is we want the ability to be able to support those applications along with the other non-real applications that you may deploy today, right? And second is we want to simplify that, and we want to give you the ability to be able to manage a lot of these edge sites using a pull-based architecture and zero-touch provisioning. And what we mean by that is, we don't want you to have your folks, before you deploy a site, have a 60-page deployment guide, and it takes 2 months to configure the cluster before you ship it out. We want the edge sites to be deployed on site where a non-IT personnel can simply connect it to your uplink, a WAN link at that site, and automatically have them come up and get to a desired state configuration. And then last but not least is we want the ability for you to be able to run your existing virtual machines that you currently use today for operations, but then at the same time be able to run modern workloads that are containerized, right? That you may be looking at deploying today or that are already deployed. And we want you to be able to do that effectively and with scale and be able to do that at hundreds, if not thousands of locations. And why this is important is if we drill down on the left-hand side, right? In a typical data center deployment today, where you have, really compute is not really a problem, network connectivity is not really a problem, vCenter works great for that model. If you have 17 clusters and they're all connected via, 25 gig links in your data center, yeah, there's no problem in terms of managing those clusters from a vCenter. But now if you move that 17 clusters to your manufacturing site behind an OT network, first, what do you have to do there? The vCenter always initiate connections to the cluster. So you need private connectivity first, right? Or VPN-based connectivity. And then you're gonna have to go punch holes in your DMZ firewall, punch holes in your IT firewall, punch hole in your OT firewall for that connectivity to happen from the vCenter to that manufacturing site. So we want to, and that's the model that we hopefully will not have customers to go through. So which is why we came up with the Edge Compute Stack and using the agent-based deployment that you use, or I shouldn't say agent-based deployment. It is EXXI hypervisor that's running on the host, right? But then we have a Edge Compute Stack control plane or an agent that runs on top of EXXI that is always phoning outbound, meaning that it's always connecting outbound to the orchestrator. So you don't need to do, the punching firewall like I mentioned, right? So if you look at this as you have the VMware Edge Cloud Orchestrator on the upper right, which we talked about in the last slide. You have the host itself, and then you'll see in there are multiple services that are running. One is the control plane, which talked about a little bit, which is the agent that phones home and connects to Git repo, etc. It also automatically bootstrap the host with a Kubernetes control plane and a single node cluster worker node, like I mentioned just now. And then there is an upgrade service that when there's a need to upgrade the agent or the host itself, it's there to do that. And then along with those services, if you have any existing virtual machine workloads or VMs that needs to be run, they'll run alongside both these worker VMs along with the control plane and other services. On the upper left there, you have the Git repo that the host or the cluster of hosts needs to connect to get to their desired state. And that Git repo can be on-prem, local to that site where there's no one else in the world have access to, right? Could be a GitLab instance that is actually locally running at that site, or in our demo use case, it's actually a GitHub repo that deployed on the internet. And then along with that, you will need to prepare essentially content, right, for your applications. So whether it's a registry for your containers or let's say a HTTP endpoint where you're storing the OVAs for the VMs to be deployed, okay? We talked about this a little bit already, so I won't repeat, but on the left is, a typical model that is deployed today, right, where it's a push mode approach where the management plane actually keeps all the configurations and state of your edge node of your node device or of your nodes and hosts. So in like vCenter, for example. And then on the right is the approach that we are using for the Edge Compute Stack, where the hosts or the edge node, right, that are deployed, on the cruise ships or in your manufacturing site or in your retail store is always calling home and heartbeating periodically, but then ultimately the configuration is living in a Git repo, and the host will always try to achieve desired state with that Git repo, right? So kind of workflow is the node comes up, the agent phones home to the orchestrator. After you activate the node and authenticate it, meaning, okay, it's a real device that I actually deployed, I want to activate it. Then the orchestrator will tell the node, the EXXI host, here's a Git repo that you need to associate yourself to. And then from there, the agent will then utilize Flux CD to basically maintain the desired state with that specific Git repo. In that Git repo, you will have configurations for virtual machines that you want to deploy. You'll have configurations for the EXXI host that you want to configure. So it could be a new vSwitch you want to configure, or it could be an NTP server configuration, DNS server configuration. And then you would also have your containerized workloads that are decorative in Kubernetes, in the Kubernetes YAML files that you want to deploy. And automatically we will deploy those containers. We'll automatically deploy those applications that are containerized using the worker node VM that is bootstrapped by default. Okay. Okay. So I think we kind of talked about this quite extensively already about how GitOps works, right? So you have your configuration files that are configured and stored in the Git repo. And then you, in a typical deployment, they will go through a CI/CD pipeline where you go from, I think Shao, you'll help me here.
Yeah.
Dev, staging, and main,
Production,
right?
yeah.
And where before, after you test and deploy everything, only at that point, then you have few folks in a company that actually allows that application to be deployed in main. And usually that's a very high bar, right, before anything gets deployed in production. So. Okay, and so this is just examples of how we do it, like examples of the different YAML files in the Git repo that we use for Edge Compute Stack. So in this case, right, on the right is actually a YAML file for configuring NTP servers for that specific host, where it's written in a YAML format, and then essentially when the agent grabs that YAML file, it will know to use VM servers that are running in EXXI to automatically configure the NTP servers using this YAML file. Another example here is a configuration of a virtual machine, right? And this is done using the VM operator, which is a CRD in Kubernetes. And here's just an example where you're able to deploy a VM, looks like a Photon VM, and then you're defining the size of it, the network that it wants to use on the VNix, and just another example of that. So in the bottom there's a snapshot of how things would look like on that particular host, right? And we're showing that when the node comes up and it's activated, there's always a worker node, a Kubernetes worker node that's running to run the containerized workloads, and then along with the other virtual machines that you would typically expect, right? That runs your environment to operate, the existing applications there. And this is just another example where we're saying that you can, obviously use the YAML file to change the size of the worker VM that you deploy. If you have lots and lots of containerized applications that are running at that particular site, node, or cluster, then you may want your worker node to be bigger than, let's say the 4 CPU and 8 gig of memory. You change it to a particular size that you need it to be. Okay, here's just another example of a containerized workloads, in this case, Nginx in a container. That's where the image comes from, Docker Hub, that you would deploy, and this is how the YAML file would look like. So we're kind of just trying to tell you that we don't just support Kubernetes and containerized workloads on the Edge Compute Stack. You can deploy, your VMs that you currently run today. You can configure the EXXI host infrastructure as well using the YAML files. Okay. So that being all said, what does the actual deployment look like? I think we described a little bit of this already, right? So first, you have a server, a hardware device, and you have to image it just like your existing EXXI host, where you would, let's say in a simple case, plug in your USB to do the installation, right? And during that installation, like I mentioned, the host itself will bootstrap the agent, which has the Kubernetes control plane as well as a worker node. And then from there, in the Edge Cloud Orchestrator, in the VMware Edge Cloud Orchestrator, or you see there it says VECO, V-E-C-O, is VMware Edge Cloud Orchestrator. So you log in there, you configure the site, and during the installation, the host will be assigned a activation key, or you can also use the serial number as well. But then you go to the orchestrator and you say, okay, I have this new cruise ship that needs to be coming up in 5 months, or 5 months a lot of time. Let's say in 2 months, and I want to go ahead and provision the cluster in that site. I would add the site, I would add the host using this activation key. You're basically pre-staging the configuration. And then inside of the Edge Cloud Orchestrator, you would associate a particular Git repo for that particular cruise ship, right? Actually, we're gonna show an example where you can use a tiered hierarchical Git repo structure to be able to deploy like hundreds of locations using the same Git repo that have all of the existing, like all of the possible containers and VMs you want to deploy, but then you can leverage customize and Flux to specifically configure site-specific configurations. So we'll go through that demo today.
Right. The goal is that, when you have thousands of sites, right, sending a vSphere expert or Kubernetes expert or some application developer to every single site is not realistic, right? You want a zero touch. You want to ship it to some, store manager, or you want to ship it to some, like a manufacturing operator, right? Where they don't know anything about vSphere, they don't know anything about Kubernetes, they don't know anything about, how do you debug reading logs, right? You just want to give them a hardware, and then you plug it in. It's all about zero touch, right? Zero touch is extremely critical for you to scale the edge sites. If you have to send people, then it defeats the whole purpose of why, that's what's preventing people from scaling the edge. And then think about AI. Can you even hire that many AI experts to deploy your computer vision app at the edge, right? How do you even know you're inferencing correctly? Yeah. So this is all zero touch is the most critical. The way we made it so simple, kind of like what Ken was saying, right? All you need is a serial number. Everyone knows what you could tell that. You just go to the back of the chassis and read that number and plug it in. It will just automatically call home and do its thing.
Yep. Yeah. So after you pre-stage it, you configure the node or the cluster that you want to bring up. You ship the device to the site, and then you have a non-IT personnel connect an Ethernet cable to that device, and then that's it. From there, it phones home to the orchestrator, and then once it's able to connect to the orchestrator, the state of that device in the orchestrator would change from registered to not active, and then from there, you have to specifically activate that device to go into an activated state. And then when that node is now activated, it will get the configuration for that Git repo that it needs to reach out to grab the configuration, and then it will automatically provision itself using all of the YAML files that you have configured in the Git repo. Okay. All right. So from there, it automatically will always try to achieve desired state because there is a Flux controller that's running on the Edge Compute Stack node. And then it's checking in every single minute. And whenever there's configuration deviation, where there are commits to that Git repo, it will automatically pull down those changes and then reconcile to whatever desired state you have configured, right, in Git. Here's the demo that we want to demonstrate today, right? And we want to demonstrate a tiered Git repo structure, and we'll explain that, or Shao will explain that in a little bit. But this is how the demo is structured. So we have 3 sites, right? In the bottom here, you have site 1, site 2, site 3, where site 1, you want to deploy all of the containers and virtual machines, that the apps. Site 2, you want to deploy all of the containers, but only the Windows VM, but not the Linux VM, for example. And then in site 3, where it's a site that only needs containerized workloads and not VMs, so you're only going to deploy containerized workloads. And we want to show you basically how you can do this across hundreds, if not thousands of sites by utilizing Kustomize to be able to do that. So you have a base Git repo that has all the configuration for all of the apps, right? All of the workloads. And then you have folders, a second repo that uses folders like site 1, site 2, site 3. And then in there, you'll use Kustomize to either remove certain VMs or add another container, etc. Okay. And so site 1 and site 2, we've already set up in the lab, but site 3 is the one that we want to demonstrate today. And it's actually a NUC that's running right here underneath the desk. So here's a site number 3. It has not been activated. We connected this morning, thanks to a gentleman, the technician that's on site here, and it's running, right? It's up, but it's not been activated. And so that's essentially the site that we want to do the demo configuration with today. Oh. All right, hopefully. Uh-oh.
What happened there?
Did I press something?
Oh, there you go. It's good.
Okay.
Yeah, so we're going to show you the goal of this demo is to, like, normally you have like an empty server, you have a USB drive, right? So it would take like, I don't know, a few minutes to install the ESXi, but we won't bore you with the details. So the ESXi is already sort of, pretending like, the previous PowerPoint you saw, like, where you put the thumb drive and then there's a, like auto boot and all that stuff. So we get to the point where the ESXi is already installed, we plugged into the wall, and it reached out and is calling the management portal to say, hey, please admit me, right? Go ahead, Ken.
Yeah, so you're looking at the VMware Edge Cloud Orchestrator right now, and the site that we want to activate is this one that I've hovered my mouse over, right, which is the site number 3, and you can see the activation state is not active. And not active meaning that it has an uplink and it was able to reach the orchestrator, but obviously you don't want things just come up, right? You want to be able to control when it needs to come up. So now we've started this site, we're trying to deploy it. I'm going to go ahead and just click on this site, and you can see this is the VM kernel 0, VMK0 interface, that IP address that it got from this network that's local here. And then I'm just going to go ahead and activate it.
And before you do that, we want to show them the ESXi console where it has nothing.
Sure.
Okay.
Yeah, so also you can see the repo that's associated with it, right? So this is actually my public repo. If you go to it right now, my handle on GitHub is k-guo. And if you go there, you should be able to see this Git repo that's named veco-demo if you kind of want to follow along as well. And so that's the Git repo that is associated with this particular site. You can see that we want to only use the VMs or only use the YAML files that are in this particular path, which is site 3. So the structure here is you have site 1, site 2, and site 3 here. And so what we want to deploy is in site 3, we want to deploy everything that's in the base Git repo, right, which is defined by this specific YAML file here. And then you can see what we're doing here is we're leveraging customize to say at this site, I want to deploy everything that is in the base Git repo that's named the veco-base CFG, which is a separate repo, but it's also, that it's basically, you can think of it as a base repo where it contains everything, right? And then you want to use this folder structure of site 1, site 2, site 3 in a separate repo to selectively choose what you want to deploy from that base repo, or even add new configurations or new containers you want to run at this site. And so in this case, we said, okay, we don't want to run any VM. So we don't want to run the Linux VM there, and we don't want to run the Windows VM there, all right? So along with it, there's a couple other things. This is an AI application that we'll demo at the end. So first is, I'm going to go ahead and grab this IP address here, which is the ESXi host that's local here, which is this guy right here, right? So I'm gonna log into it. Usually this local access will be locked down, but obviously this is a demo, so I'm showing you the workflow. So now you log in and you can see if I go to the virtual machines, you will not see anything except the Kubernetes worker node, right? So here's the worker node. It's actually not running at the moment, and because it has not been activated, okay? So nothing's going on. You ship this site on site, let's say a personnel on site plugs it in, and then no one can do anything at that point, right? So the device will not do anything until you activate it in the orchestrator. I'm going to go to the orchestrator. I'm going to go ahead and activate it. So I select this node and activate, right? So at this point, what's going to happen is the orchestrator is going to tell the device that it's getting activated. Actually, there's a lot of things that also happens in the back end. So if there's a TPM chip that is included in that host, the EXXI will go ahead and use that TPM chip to essentially create a certificate, right, to be able to authenticate with the orchestrator, etc. But on a very simple, very high level, it phones home, it gets activated by the orchestrator, and then at that point, it will go ahead and start deploying all of the configurations from the Git repo, after it connects to the Git repo. So from here, the Kubernetes control plane that's running on this node right here, it'll take a couple minutes, I think, to get everything running. But in the Kubernetes control plane here, we'll start the Flux CD controller. It will start customize. It will start the worker node as well, and then it will automatically connect to. You can see it's starting the worker node now. It'll automatically connect to this Git repo, right? veco-demo that we assigned to this particular site, right? So.
Yeah, while we wait, maybe we show them how we can add the steps we added.
Which steps? Okay.
It's just onboarding.
Yeah.
And host.
Yeah, I did forget that part. So how this works is, first you download the image you need to deploy the host, and then from there, you would add a host. So we did this yesterday, obviously, but this is how you can add it to the orchestrator. So you can add it using the model and the serial number, or you can add it using an activation key. And then from there, you can associate it with a particular site. A definition of a site is kind of like a cluster. It's a template, right? Where if you have multiple devices that share the same configuration and same Git repo, you can assign them to the same site. And then from there, you associate the Git repo that needs to be associated with that particular device. So let's say if I associate it with site 3, which is the one that we're trying to bring up, right? This NUC that we're trying to bring up here is site 3. Then it would automatically populate what was already configured in the Git repository section of Orchestrator. And then from there, you simply add the host. So after we add it, we kind of get to the step earlier. I kind of went a little bit ahead, but you get to a point where the node will be added over here, and then it will be in a not activated state after the device connects to Orchestrator. So the order I just went was opposite, right? You need to add the host, and then it connects to the Orchestrator, and then you activate it, right? Okay, so now everything is running. You can see that if I refresh site number 3 here, you will see that the worker node is now running, right? So I should be able to go to the Orchestrator now. And I've got a worker node IP over here. And then now I do want to show you that there's the base Git repo. And this is everything we want to deploy onto that. Sorry. There's a base Git repo. And if I look in the base folder, these are all the configurations that we've configured in the base repo. And if we look at the Kubernetes cluster, these are all the different applications that I want to deploy, right, into that worker node. And specifically, I'm going to use the Kubernetes dashboard as an example here. And in this case, we're using a node port of 30,090, I believe. Yep. Okay, so now knowing the worker node IP right here, I should be able to just go to this IP address on 3090, and I should have, right, this Kubernetes dashboard that's deployed. And you obviously can do the same for other applications that are running. And if I look at this, you can see all of the different apps that are currently deployed in this worker node VM, right? Nginx, there's Grafana, Prometheus, and then including the AI inferencing application that we're going to demonstrate towards the end of this session, right? And this is all done, you can see, literally with my one click of activate in the orchestrator. Okay. Maybe I'll pause here for a second. Like, are there any questions that we can address right now? Okay. I hope it all makes sense. Okay. I see some nods, so that's great. Okay. Okay. I think this kind of concludes our first part of the demo. So now we're going to have Xiao go over the Flux CD part, and we're gonna go over basically like how how the structured tiered Git repo kind of work, right, with the Edge Compute Stack. Okay.
All right, so thank you, Ken. So that was the first demo, and so I think Ken already covered a lot of this. I'm not gonna try to repeat everything he said, right? So the way it works, the internal guts of it is you have this Flux, right? In the industry, you may have heard of like Argo CD. That's the other well-known, GitOps operator. So Flux is what we use. It's very, very powerful. And then, I'm gonna try to walk you through in terms of the goal for Edge is you develop once, you push everywhere, right? And then you want to have as much control as possible. So this is how it works, right? So you have basically what Ken just showed you. You have a Git repo. In the Git repo, you could have infrastructure configuration, or you could have application configuration, right? It's all sitting there. And what Flux does is Flux just constantly checks every 60 seconds. Like, do you have anything different, right? So the way he checks is that every committing you do in Git has a hash, right? So, it checks on the hash ID to say, okay, has the hash changed? If it changed, it's going to take it over and pull it, right? And then depends on the configuration. If it's infrastructure configuration, like for example, Ken created a VM, you will call the vSphere, the VM operator. It has under the cover, it do all the SOAP API calls to create the virtual machines and everything, right? And if it's Kubernetes, obviously just send it to Kubernetes API to deploy. And then all that information that Ken just did shows up on our dashboard, right? So if you go to, like later when we go back to the demo screen, you could actually monitor every single time, every 60 seconds, when Flux is, polling and making changes, we put the state. If something fails, you'll see it there. Right? That's the Flux runtime status, right? We want to know if an application didn't deploy, right? You want to see it. So that's what happens there, right? So you could, the type of operation you can do is you can update application, right? I think Ken is going to demonstrate this. It's like we're going to change the release of the application from release 1 to release 2, right? Or you can delete something, or you can, scale, instead of, especially for Kubernetes, 2 replicas, maybe you can make it 5 replicas, right? Depends on the state, and also the monitoring. You can monitor this, and Ken is also gonna demonstrate how you can. We have a built-in monitoring is very, very critical for everything, right? So we're gonna show you how we can have local monitoring for that specific NOC host we just deployed, and then be able to look at the VM runtime as well as the container runtime status, right? We're gonna show you that to you. But anyway. So in terms of Ken just went over all the type of YAML that you can define, VM operator, Kubernetes, right? But then how do you get to the define ones or design ones, right? Implement ones and then push everywhere, right? So there's multiple strategies behind it. You could start off with what we call the shared repo. I think for those of you that's doing software development in the past, they've been using GitOps. They're using source code control forever now, right? So they commit everything into Git, And then they have different branches, they promote different things, right? Now, in the simplest scenario, not that we're recommending this, right, is you can have one repo that has everything in there, your application code as well as your infrastructure code. And then you could have folders saying that, hey, for site 1, here is what I want to deploy, and for site 2 is what I want to deploy. So you basically, the good thing about this is there's less dependency you need to track because everything is in that repo, right? That works well when you have a very small team, a very small project, right? It doesn't involve a lot of people. So it goes back to our very first slide when we ask you guys, what do you guys do? Most organizations have, QA, developers, infrastructure admins, right? So the mono repo is on the one extreme. It's like, hey, I just do one repo, and then that's gonna pretty much, I will have everybody work from there. Or you can go to the other extreme because they have, a lot of the government agencies, for example, have very strict process. Like if you are doing application development, you're not allowed to touch those sites. And even within the site, they may have very granular control and says like, if you're in this region, you only XYZ person can touch it. And then if you're in a different region, only like another set of people can touch it. So you can go to the other side where you could have a repo for each site you deploy, right? So this is like the two extreme. And then in the middle is where, depending on your organization, right, you can sort of figure out what is the best way to group. Git is about collaboration, right? It's about everyone contribute and then not stepping onto each other, but everyone can work from a single source, right? So you can, based on the org you have, you can say, you know what, maybe I can do a Git repo per team. Like for example, if I'm writing this, AI application that's doing computer vision, I could have one repo for that, maybe, right? Or maybe I could do it based on the application. Maybe you have one team that has multiple apps they support. You could have a separate repo for them, right? So there's a lot of possibilities. And I think the first part of, sort of having supported ability to scale your edge deployments to 1,000 sites is making sure that you come up with the right collaborative approach that fits into your organizational processes, right? And you don't want to be unless you're having some really small deployments, you probably don't want to do a single repo. I mean, if you have very strict processes, very tight security, unless you have that, you probably don't want to have a repo per site because you're now shifting the process we talked about in the beginning, like micromanaging the details to the Git level. You don't want to do that, right? You want to find the happy medium that makes the most sense for your org, right? And so that's the first thing is like, in order for you to scale your edge, figure out what the repo structure should be. And our recommendation is have at least 2 repos, at least 2, right? One for your infrastructure, right? And because most of the time your infrastructure configuration is common, right? You have X number of NICs, you have NTPs probably set to the same source, right? So having, or maybe you have GPUs defined for the applications you want to run, right? So having maybe like an infrastructure and then, like having at least, infrastructure specific, and then having like application developers do what they do today, keep it in their own, Git repos so that they can integrate it into Jenkins, so that they can do their builds, and then so they can publish the images they do into the common repository, right? At least 2 repos. So that's the first, and we spoke to a lot of customers, and they, the ones that sort of design the repo strategy correctly are the ones that can pretty much sleep well in the evenings, So, and the other thing is like, if you try to have everything crammed into a single repo, trying to define isolation between sites becomes very difficult, right? So that's another reason why you don't want to do a single repo. And then if everybody, one of the things, if you read the GitOps from a best practice perspective, right? And which is, I think, the next slide, is that, like traditionally, with Git, and if for those of you who has been sort of involved with working with the development team a lot, they tend to have different like branches, right? So they have a dev branch, and I kind of sort of didn't include it here, right? And then once the dev branch is done, they merge it into maybe the QA branch, and then the QA team will test it. And then once everything tests out fine, it goes to staging branch, which should look very near identical to what the production looks like, right? And then everything tests out staging, they go to production, right? Now, this right here, in fact, actually for GitOps is not a good practice. The reason for that is, when you have, if you think about your cloud native application, right? It's all about like ability to burst, right? You want to sort of start off with different, like, it's like containers. I don't know if have you guys, I think you guys have it in your deployments, right? So maybe in your dev environment, you only have 2 replicas, right? But then when you go to QA, they may say, I want to test it up to 5 replicas because this is what the minimum requirements are. But then you may have a staging environment that needs to resemble the worst case scenario. So trying to create all those different merges with Git, when you have different sort of environment settings, becomes extremely difficult. That's one of the reasons why we don't recommend to say, like, having, the traditional CI/CD process where you have different branches per environment, because it makes merging very, very difficult, right? And on top of that, you may apply hot patches. Like, for example, let's say that there's some sort of a vulnerability that was identified. A lot of times people go straight to production, say, what, I have customers that needs to be protected, and then you will apply a patch right there in the production environment. Then that creates a merge problem too, because, you have something that's running production that looks different than staging, right? So I think, one of the based on all the customer we talked to, with the actual traditional QA, staging, prod, and then having dedicated repos mapped to each is not something that scales very well, right? Instead, what scales very well is, how many of you have used Kubernetes Helm charts, right? So yeah, with Helm charts, you have what's called value.yaml file, right? And then for each environment you have a different value.yaml, right? So effectively it's a different folder, right? So this actually, the folder per environment works really well in GitOps because it resembles the cloud native design patterns that's already out there with Helm and with a lot of the application deployment. So you will have, instead of you having different branches, you have a different folder, right? So you have a folder for QA, and this folder will have your quote unquote value.yaml for your infrastructure, for your application, right? And then once you finish your testing on the QA branch, or folder, right? I keep saying branch, it's like hardwired into my head. Then you copy the value.yaml to your staging, right? And then you update your YAML file, right, with the environment settings for staging, right? You test it there. And then once that's done, then you go to your specific sites, and then you define your environment YAML files, right, for individual sites. And then I think later on, we're going to demo, like Ken already actually went through all those different permutations. He's talking about using customize to override settings, right? So there's a lot of flexibility in Git to allow you to do that. So the right hand folder per environment, our customer find that to be extremely, it reduces amount of cherry picking. Effectively, when you use different branches per environment, you end up doing a lot of cherry pick, because like if my QA only has 2 replica, I can't just merge it into my staging branch, because my station may need to have 5 replicas, right? So you ended up doing a lot of manual process to cherry pick between different environments so you can merge. And it's pretty difficult. Those of you guys that's using Git a lot, when you have merge conflicts, right, it's not easy to resolve. With the folder-based approach, you kind of avoid all that stuff, right? When you move between environments, it's a matter of copy the YAML file corresponding to the environment, and then point it to the YAML file that's the repo behind it, right? And then just update the settings. So we have an example right after this. So that's the recommended way of doing promotion, is having environment specific. So what does that look like in a real? And this is what the demo looks like actually. So this is what Ken's. All the sites we have follow this pattern here. So we have 2 repos or 3, right? So we have actually 3 repos. So you will have an infrastructure repo, right? And we put all the ESXi configuration, vSwitches, NTP servers, right? All that stuff in the ESXi config. We have a common VM configuration, right? Whether it could be your Linux VM with X number of CPUs, right? So, and then we have your common Kubernetes configuration. This could be your dashboards. I think the one that Ken just showed you, right? Every single site we deploy have, basically the Kubernetes dashboard, because that's for monitoring. That should be common. There's nothing specific about, the default dashboard we should send out, right? And then, like if you're doing, GPUs, for example, right? So usually if you're running NVIDIA GPU, you have a certain set of configuration you need to apply to that, right? So you have a folder for that. And then, so this is your infrastructure, repo where you already certified the configuration to be the golden config that you want to run, right? And you keep that. So this allows you to develop once, right? The goal is to do as little work as possible. Right? The more work you do, the more iteration you do, the harder it becomes a downstream problem, right? It becomes more operationally complicated to support it, right? So the idea is put everything that's golden that should apply, kind of like C++, right? You always have like your base class, and then you kind of write, classes to override the base. That's the same principle, right? Object-based. And then, so then you could have a site-specific repo that contains all your environments, right? So in that environment, the idea here is like, let's pick and choose what is applicable to that site, right? And then maybe there's certain things that's very specific to that site. Like one of the example we're gonna do after this is monitoring. Like I may have a dashboard that looks at just the ESXi host on that site, right? So I don't want to inherit from the global part. I mean, I could do like some sort of a customized patch to say replace the IP address, right? Or I can just deploy my own, like YAML file to say just write the data to my local Prometheus server or something, right? So you're gonna have site-specific configuration YAML file. You can just load it into that folder, right? And then you could have application, this is what we talked about before, like, be able to have developers having teams maintaining their own autonomy, right? They don't need to worry about, what infrastructure I'm going to deploy it on, because that's, you guys are already doing all that great work, right? They just need to worry about, here's my app, and here's the repo that you can point to. And then every time I put a new app over there, we don't need to do so many different meetings, so many different planning exercises. As long as you trust the work they do, you point to their repo, they update it, they release their code, and then they ship it to the locations that they need to ship it to, right? So it's very,
pictures are worth 1,000 words. A little bit of time constraint, so let's get to the next demo.
I think we've got 90 minutes.
Yes, we have 20 minutes left.
Oh, really? Okay,
yeah.
All right. Sometimes I get too excited.
Yeah.
I lose control over my excitement. So this is scalable, right? And it allows you to, just one last thing on this, because this is a very powerful slide. It allows you to develop once, right? It allows you to push everywhere. And they give you the knobs because of Flux to make changes that's specific to a site. So you have control, right? So you're not sort of stuck. It's like, I can't deploy this. I have to make my hardware to look exactly the same. No, you don't have to, because the operator will do that for you, right? So, yeah, so I think that's the, I think, Ken, you already did this demo. And I think now what we wanted to do is we want to override the ability to take the global base config, which Ken already showed you, and apply a site-specific change, right? So, so Ken, I think this is, actually,
Yeah.
I think you already did this.
We can demo this really quickly. It's
yeah.
very fast. Yeah, if you could, how do we swap over to my screen again? Shao? Oh, okay. Yeah, so basically we want a tiered repo approach, right? So you have the base config repo right here. And in the base config repo, you can see there are two folders here. One is the actual base configuration, and then there is the infrastructure config, Kubernetes config, monitoring config, and then any virtual machines that you want to deploy. So in this case, there's a Linux and Windows VM, right? And then the secondary repo, which is what we use in the VMware Edge Cloud Orchestrator, right? So this is a site, the NUC that we deploy today. It's using this specific Git repo right here, and then it's using path of site 3, right? And so if we look at site 3, this is the repo, and this is site 3. And what we're doing in site 3 is the site 3 YAML is using the base Git repo, which, which like Shao went over in the previous slide, which is the one sort of the infrastructure, or I should say the base repo again. And in here, what we're doing is we're customizing that using the tool Customize, and I'm basically deleting the VM, the Linux and Windows VM at site number 3, okay? Additionally, we're also adding a AI inferencing app here, and then along with a Prometheus, we're updating Prometheus, right? Yeah. So kind of show you how that looks like is, this is site 1 that we deployed in our lab, and then we're deploying site 3 over here. So, this is site 2. So site number 2 is all container apps, along with only the Windows VM. Site number 3, which is this NUC that's running on the desk here, is only containerized apps with no Windows, no VMs, right? So you only see the EC worker. Site number 2, you see EC worker and Windows. And site number 1, you see EC worker along with the Linux VM and the Windows VM. And how we do that was using the base Git repo where it has everything. And then the secondary repo, which is the one that's assigned in the VMware Edge Cloud Orchestrator, we're using Customize to be able to make a configuration change to that base Git repo. So site number 3, I delete both of the Windows VM. In site number 2, we deleted the Linux VM, right? And in site number 1, there are no changes. And we simply just, in this case, I'm showing an example of how do I change the size of the Linux VM that we want to deploy. So to show you what it looks like when you make a change to the global base repo. So over here, I'm going to go ahead and delete this client. It's a YAML file in the base repo, and that's just basically a delete Linux container, okay? And that's what the client YAML was for, right? So I'm gonna go ahead and sync it. And what happens in a second is I should be able to go into the base repo. Gonna go ahead and refresh. And we should see the git commit that was just done right there. So there's the git commit that was done. It removed the Linux container. And now if I go to my third, so just now I ran this command about, you can see the timestamp there, about 10 minutes ago. And so now if I do it again, well, let's wait for 1 minute for Flux to update. right? So right now, what's happening is the Flux controller that's running on this specific NUC right here, which represents site number 3, it is getting an update, right? And once it gets that update, it will go ahead and delete the client app. Okay.
Did you commit it? Oh, you did? Okay, 1 minute ago.
Yeah.
Yeah.
So it might take a little bit longer. So interesting. Yeah, there it is. It should go ahead and get deleted. Okay. Yeah, let me check the base
Yeah.
repo again.
So maybe we can just
Okay. All right. Well, we'll troubleshoot this later, or maybe we'll check in a little bit. But it should go ahead, basically make the Flux controller should make that change and then automatically remove that container, right?
Yeah, Flux is very powerful because this customized controller here basically defines what you want to push. Is in what you have in the base. The moment you do that, unless you have override on the site-specific repos, everything should be pushed out, right?
Yeah.
So this is what allows you to develop once, push everywhere. It's more powerful when you add new certified applications. You know, it's like, hey, you know what? You just push everywhere. So
it went away finally, so you can
Okay.
see it took a little while. You can see now the client app, right, is no longer there. Trust me, I'm not a magician, so I didn't do anything just now. And if I refresh on the Kubernetes dashboard, you can see the client is gone, right?
yeah.
Okay. Can we please go back to the slide deck? Okay.
No, okay, please. Okay, cool. So the monitoring is extremely critical, right? And usually monitoring, there's 4 critical questions. That starts with what is the runtime state? We need to know if there's a problem, we need to know about it, right? We don't want to kind of assume everything's running fine, but when then something is actually breaking very badly. So we need to know the runtime state. But if you know the runtime state, you need to know where do I find the failure, right? You have to be able to sort of root cause the problem. And then also the equally important is how is the failure impacting business, right? If it's like a minor failure, no big deal. Like you don't have to sort of wake up 3 in the morning trying to troubleshoot it. You know, like, hey, it's only like a cosmetic thing. I can just go back and change it later, right? And then finally, who is the audience that needs this information, right? Because remember, I keep going back to the first slide. GitOps is as much of process and how that aligns with the organization as technology, right? So we need to make sure that the right people gets notified when there's a problem. So those are the 4 pillars that any monitoring strategy, and that's what we're trying very hard for to deliver that on top of ECS out of box, right? So let's first talk about the who's, right? So I think most folks in this room belongs to one of those categories. So it's the VI admin, the edge infra admin is what we call, right? So basically those are the people that's very familiar with ESXi. They know how to troubleshoot ESXi, and then they tend to use vCenter and VRA to sort of, get their sort of a view of how things are running. And then there's the application owner, the gentleman in the back, right? You use DevOps tools, you use Grafana, you use Prometheus, you use Telegraph, you use Logstash, you use some sort of a Kibana type of things to view logs, to filter logs, right? To debug your application, or you may be using some sort of application based on the library you use to be able to do that, right? So those metrics needs to go to the application owner so that they can isolate the problems, they can look at the trends. And then third class is very, very important, right? Is the line of business, right? If you think about it, it's like if I'm a soldier in the field, that's the most important person. He needs to know, am I ready for my mission, right? He needs to have something very simple. They're not technical now, right? The first two are very technical, very, very, they are the specialists in their own domain, right? The third persona is more of like, hey, I'm not a technical expert. I know the business very well. Like, your hotel front desk, like parking attendants, for example, right? They know how to operate the parking garage very well, but they don't know anything about vSphere. They don't know anything about the billing application. So they need to have a view too. So we're focusing, those are the top persona. And then you also have network personas. Like if you're doing SD-WAN, you need to know how your SD-WAN is running, right? But those are sub-personas within each category, right? So, and then the way we define the what, where, and how, right, is the what is the Veco dashboard give us the runtime state, right? If there's an issue with Flux, we need to see that in the runtime state. And we need to see that based on the site. We need to see that mapped to the host, right? And then we also, the line of business owner also needs to see the runtime state. They need to see like red when when something is not working, they want to see yellow when something is not running optimally, and when they want to see green when everything's fine. They don't care about histograms. They don't care about, my CPU is bouncing back and forth. They just want to know there's a problem, right? And then for the how, why, right? That's where ARIA operation come into play. We want to make sure that the primary persona keep using the tool they use to debug, to root cause, right? So if you have an issue with your vSphere infrastructure, you're going to use ARIA operations, and you're going to use ARIA logs to sort of understand exactly how, the same familiarity you have towards debugging things, right? And those are usually centralized somewhere. So that means that we need to take those metrics, those logs, and forward it to some centralized location, right? And if you're an application developer, you want to have like Prometheus, and you want to build your own little dashboard depending on the problem of the day. Like you may have a bug today on, I don't know, some memory leak somewhere in something, right? So you want to have that ability to customize your Grafana dashboard to catch the problem of the day, and you want to be able to forward the specific metrics to Prometheus so that your Grafana can start, doing it. So that means you need to have Telegraph scraping the right metrics for you. So you need the ability to push Telegraph into the Kubernetes cluster that you have deployed, right? So, and then they should be able to do that based on the application repo definition that they have defined, right? And lastly, what is the impact, right? This is where the edge intelligence, allows you to say, hey, I have a lot of failures here, but I know that I see another failure. So, and it gives you the sort of the impact of the failure, right? And that's the strategy we have, and this is how we see it maps out to the deployment infrastructure. So you have your core data center, right? Because that's where your traditional vRealize operations is running. This is where your developers probably gonna need to access because it's simple. You only go to one place for everything, right? So you have your Prometheus, Grafana, your vRealize all running inside of that suite along with all the other entities you have, right? At the edge is where you have the line of business monitoring, right? Again, that's going to be dependent on the verticals too. Like if you're in manufacturing floor, you're going to need to have a dashboard locally. But if you're in retail, then normally you don't expect the supermarket manager to monitor anything. So you still go back there, right? So it all depends. Like if you're on the cruise ship, you probably want your cruise operator to be able to see something in your cluster, right? So you need to have a local, and especially if your WAN is not available, right? You want to be able to see it locally right there. And then you want to, that's only a way, that's how you scale, right? That's how you can get thousands of sites deployed. So I think the next demo How much time do we have? I mean, this is what like a sample out of box Prometheus dashboard looks like. I think Ken is going to deploy one. How much time do we have?
We have 10 minutes.
Oh,
So.
do we want to? Oh, anyway, so
Yeah, we
have
should
two
go
more
ahead and go
demos.
to the demo. It's ready. So let's demo monitoring right now.
Yeah. Okay.
Please. Thank you.
So what Ken is doing right now while he's pulling it up is he's going to deploy a Prometheus Grafana dashboard specific to the NOC, right? We want to only monitor what's running on the NOC because that's the line of business, right? It sort of does two purposes. One is it shows you how you can granularly push site-specific configurations, right, without having to make a global change because the other sites don't care whatever that's running on the NOC, right? So go ahead, Ken. Sorry. Can we switch?
So you can see this is the YAML file that that we deployed into site number 3, and then we had to update the IP address right in this YAML file to the worker node VM. So kind of going back to the orchestrator earlier, the worker node VM is 6.32, and we had to do that. So once it updated, it was committed a couple minutes ago, and we should be able to see the dashboard now. So what is the node port IP? Node port for?
Node port is 3. Yeah, we have to look at the services. If you can just go back to the cluster view, just look at the services.
Which view?
Remember you were looking at the cluster, kubectl.
Yep.
Yeah.
Here?
Yeah, just look at the SVC, kubectl. There you go. Yeah. So look at the monitoring one. It's the. Sorry, just right here. It's the.
Is it Prometheus?
No, it's the monitoring. That is the. This is the one.
This is, we're not faking it. So.
Metrics monitor. Anyway, maybe we can just go over the other ones and then we come back to this one.
Yeah, it'll just magically work like the last
for some
one.
reason I didn't see it there yet. So.
But the last part, I think the last part of the demo we want to demonstrate is a computer vision application, right? Xiao actually wrote, and this is the YAML file for it. And we just want to demonstrate ability to use a pass-through iGPU on the device, and then be able to use it for inferencing, right? So first is let's go back to the worker node itself, and you can see that if I look at the edit settings, it is okay. I was expecting to see a pass-through iGPU over here. So, of course, this is Murphy's Law, right? So, let's look at the settings here. I don't see the pass-through device. Okay. Okay, in a perfect world, what we should see is you should see the pass-through for the integrated GPU to the CPU here. But then if we go back to the repo and look at the YAML file, you can see that it's using a Docker container. Okay, where is it, Xiao?
Yeah, go down. Yeah, right there. Yeah.
Okay, it's right here, right?
Yep.
It's using a Docker Hub container, and we're running this container on port 30,333 here. So if I take the worker node IP, go to that port, this is what we see here. So it's trained to recognize essentially tanks, right? So if I go ahead and submit this, you can see that it says, okay, it's 81% accuracy that this is actually a tank. And just I'm not sure exactly what's going on, but it's definitely using the iGPU. Otherwise, it would take much
It's my
longer
code that's
to do
written so well.
inferencing.
It's extremely fast. Everything is, it's refactored to
Okay.
the. So yeah, so but the goal is this, right? Is you're not, what we trying to strive for is help you guys reduce the need to upgrade hardware everywhere, because you could run computer vision using CPUs today, right? And as long as you have the right model built, right? And then as long as you are using the right image sizes, like for example, if you look at this, look at one of the things, can you show the, like you have a 320 image versus 640 image, right? You have this is the image size, right? Depends on the image size. If you look at the first image,
Yeah, it was 78% and then it went to 54.
no, but just show the other one, the tank, where the very first image, right?
Okay.
So you actually can detect more things. So right now, it doesn't detect the truck, right? And if you go to the 640, right? So now, the car gets detected as well. So there's a lot of things you can tweak on your inferencing. If you look at the third image, for example, right? 640 image allows you to detect multiple, tanks that's coming out of the water. Obviously, if we can use a larger model and train it a little bit more and like doing the labeling a little bit better, we can probably detect all the ones behind it too. But if you go back, like for us, is the 320 can only detect the first one, right? So again, like you could leverage your edge hardware, what you have today, to do computer vision, and then it depends on the requirement, right? So you could actually do a lot of things without having to purpose GPUs, because we support everything. And now, if you lay the Git repo correctly, and the other thing we didn't talk about in monitoring, which we spend a lot of time working on, is how do I know my AI inferencing is drifting, right? Because like that number you saw there, 81%, and then the other one says 79%, whatever the number is, I don't really care. But what's important is we need to be able to, as part of the monitoring, right? We're building this strategy where we want to first allow you guys to deploy models at the edge simpler. Be able to have your serving model so that you can decouple your code and you can push the trained models to that. So that way, if you have a better, like having telemetry to say, okay, my drift is not good, I need to go back and make changes, right? Allow you guys to deploy the models without having to touch your application, right? We want to have an AI-ready infrastructure with monitoring built in so that you guys can consume that. That's what we're working towards. And I think that's what Ken was saying.
Can you tell me what the version is, latest versions? Like we
Version
can show
3.
version
Right.
3?
Suppose like I want to detect, I don't know, airplanes now, right? So that was detecting tank. So now let's try to say like, I want to actually detect airplanes. And so without, there's already models that's developed, right? So I think what Ken is going to do is he's going to upgrade through GitOps, right? Without having to go into Kubernetes, making all those deployment changes and then, and then go to 1,000 sites and trying to make all those changes. He just did it once in GitOps, right? And then give it like a few minutes, like maybe a minute, because we pull every 60 seconds, right? So we should get the version 3 code downloaded, and then he should be able to go back to the same port, now start inferencing without having to do hours and days of work, right? You see that? You see it's terminating the old one? The new one is coming up.
Okay, I think it looks like it's updated. So now
Okay.
if I go back here, how do we verify the improvement here?
Actually, no, it didn't update because it still says YOLO 320. It should be, it's not just.
I think this is a new one that came up 11 seconds
Okay, just give it another second. I think it should be.
I'm sorry?
Just can you check again? Make sure the other one is gone. Okay, cool. Can you check? Can you go back to the portal?
Yep. Okay.
Yeah, see that? Now let's just use the classic out-of-box model. Cuckoo dataset is the most popularly used, right? So if you can load the pictures I sent you.
Yep.
Yeah. So now we want to expand our model to include other objects, like airplane, right? So just click on the little red icon.
This
Yeah.
one?
Yeah. Hold on, let me check. Sorry. Where do you have your pictures?
A desktop.
Desktop? Okay.
Yeah.
Yeah, so like here's my airplane picture, right? I want to detect it. Now it's detecting airplanes now, right? Before it was detecting airplanes.
Before it was only doing tanks.
Yeah.
Now we got
So now
airplanes.
I could also detect people too. Let's see if we can look at, like have a bunch of people sitting in the park, and we could start looking at like all those. In addition to tanks, we can look at phones and all the other things they do. And he doesn't even have a GPU running. So that's pretty, Any questions so far? I know people have to go.
Yeah, if we can swap back to the slide deck, please. Okay, so that's actually demo number 4, right? Is deploy and display app, and then once we change the app version from Git, it automatically gets pushed to the edge devices, and you can do this regardless whether it's one site or hundreds of sites, obviously. Okay. We're running really towards the top of the hour here, so I'll do a quick summary of the best practices, right? And again, is with Edge Compute Stack, we want to leverage GitOps to be able for you to do, source control, version control, and also proactive updating automatically, right? Without manual interventions. And then whenever there's configuration deviations, Flux should take care of that drift and then reconcile your entire infrastructure. And then secondly is leverage hierarchical templates and Git repos to be able to achieve your goals easily. But then also kind of from a security standpoint, you probably want to separate your Git repos based on regions as well, right? Or based on common configurations. So I think best practice is if you have low number of sites you have to manage, but very high, like every site is configured very differently, then it's better to use one-to-one mapping for the configuration. But then if you have many sites where all your goal is to deploy a CV application that's recognizing people approaching a building after 12 a.m. and that's all you have to do at every site, you want to leverage a hierarchical model where it's a base repo and then you make very small changes at a very small number of sites if needed, right? Okay. And then obviously is we will provide the tools for you to do to deploy monitoring infrastructure and to be able to do that easily. Like we showed is in the base Git repo will allow you to deploy the monitoring containers, and then at a site basis, you can also deploy your site specific dashboards that might be something you develop internally, right? Okay. So I know we're a bit over time here, but are there any questions before we wrap up here?
So when can I replace so I use we call it the RA, but they changed to RAODC, and I don't like clicking around so much.
Yes,
and
of course.
I'm using the life cycle, like you can get all of your stuff and store it and get using the lifecycle manager and push it back, but it's not GitOps. Is there any plans to use like something a little bit more? Because each of ours we're running full clusters, and not edge. We might have some opportunity to do some of this as well. Because we do a lot of. It's kind of like It's Disney cruise lines, so whatever.
Yeah.
You know, it's like a resort.
Yeah, literally, I think your resort could have a data center that's running vCenter, ARIA Ops, right, for sort of a data center monitoring, and then at your remote sites, which could be a camera that's at a particular pool location, that could be an edge site to you. So your question is,
But my question is there some way we can get going with, like, because really, I just want to know, I want to manage vSphere like this. This is how I want to be staying.
Yeah.
I mean, really, this is I mean,
Okay.
and I was reading it. So we've used some Terraform to some success, but it's still not.
Right, maintaining the Terraform to make sure that, it does a lot. Terraform is very powerful, right? It does maybe 90% of the work, but the extra 10%, if you have a lot of sites, it's a huge amount of work to just tracking, like we said earlier, right? Tracking Terraform results, so like maybe a day later to rerun the result. That's an operational overhead.
So back to your question, though, is your question about how you can push the monitoring for Edge Compute Stack to ARIA as well? Is that the question, or?
No, the question is,
How to use VRA?
how do I use GitOps to configure vSphere and my client appointment, my VM appointments? For example, like right now we're looking at using Terraform to go ahead and configure distributed port groups on the
Right.
and also add them into VRA and all of that stuff. And it's I don't know. I'm just
We-
like Kubernetes manifest. So
Yeah.
it's just, it feels cleaner to me than it feels a little bit cleaner. I definitely like it better than like HCL.
Yeah.
Yeah, we can definitely create like a new vSwitch and configure distributed port groups. We do support that. I'm not sure about every single feature that's available in vCenter. I think it'll be good if you can reach back to us and we can have a separate conversation, talk about the details of what you have to support. Yeah, great.
I have a feeling it's not good, but I'm just expressing interest.
Right. There are certain things, if you think about it, right? We are tailored for the edge, right? We want to give you the ability to scale without having people running around chasing down problems, right? Now, there are certain things that doesn't belong to the edge, right? Like what Ken was saying. For example, if I'm like one of the things that you probably you need to think about is like, for example, I think you said you have vSAN stretch clusters, right? Is that because of high availability, or is that because of like application?
It's for high availability.
Okay, yeah. So because I think most of the edge device, we need to, this is what Ken was saying, right? We need to sit down and figure out how does your requirement map, at least in the short term, to what we have, because, looking at something like a vSAN stretch cluster, right? And see if that's an edge attribute or versus this is more of a data center attribute, right? If you...
My use case is less of edge because each of our edge locations has a data site. Basically.
Right, okay.
So with full staff, IT, there's IT people, whatever.
Yep.
It's like a little city.
Yeah.
Or a decent sized resort.
Right, absolutely. Exactly, yeah.
Right. So, but I like the way you guys are managing.
Yeah.
I really like it. So.
Awesome. All right. Yeah, we're quite a bit over time here, so yeah, appreciate you guys sitting here for for the entire session. So thank you. Yeah.
Thank you.